Hi guys, all right, we are going to be comparing function values to 0. So it says which variable x or y does the function notation f of x represent? So f of x, when we see f of x, what could we replace it with? And hopefully you guys all know this to be y. All right, now it says if f of x equals 0 for a given point on the graph, then where is that point located? So in other words, where is y equal to 0? And so we should recognize that we are going to be on the x-axis. And it says if f of x is greater than 0 for a given point on a graph, then where is that point located? Where is y greater than 0? And we should recognize that as above the x-axis. And then similarly, if we were to take a look at f of x is less than 0 for a given point on the graph, then where is that located? And we should be able to recognize that that's going to be below the x-axis. So now it says we're going to use a marker or a highlighter or a colored pencil and trace the graph from left to right for any values or intervals on which the graph of f of x equals 0. So this one is going to be f of x equals 0. This one is going to be where it's greater than 0, so above the x-axis. And this one is going to be less than 0, so where it's below the x-axis. So if we were to take a look at this graph, we are looking at all of the points where the y values are 0. Here it's where the y values are above the x-axis. And in this case, we are looking where the y values are below the x-axis. Now here it says identify the x values for the highlighted portion of the graph. So this one is very specific. The x is -3, 0, and 6. Now this one has an interval because we are dealing with all of the x values in between certain numbers. Now, I want you to take a look at the idea that's going on here. This says greater than 0, not including 0, which means we're starting at -3, but not including -3. We're going to 0, not including 0, and then going to 6 and not including 6. So look at this notation. We start at -3, we go to 0, we stop, we pick back up on the other side of 0, and we go to where x is 6. Now, what would this be? So remember, there are arrow tips. Actually, I don't think those are arrow tips. Those are distinct points right here. They are not arrow tips. So we are going to where we are below 0, not including 0. So we're going to go from -5 to -3, and then from 6 to 7. So look at the difference in the way we write that interval notation. -5, because the x value is -5 and it's included, but -3 is not included because it didn't have an equal to 0 here. We pick back up at 6, which is not including 6, and we end at 7, which is included. So again, it says on this portion right here, again, should your intervals identified above be identified as closed intervals, which is brackets, or open intervals, which are parentheses, give a reason for your choice. So I just kind of talked you through that on the video. So let's take a look at how we can word that. The intervals might open, closed, or a mixture of both, depending on what is being identified by the interval and where the graph is located at. So again, because, let me give you this reason, because it told us that we wanted f of x greater than 0 and not greater than or equal to 0, that's why we had to use the parentheses. In this case, same idea, but this case it was exactly equal to 0. In an interval notation, we could have done this. -3, 0, and 6. So interval notation for that is just as good. All right, so now let's take a look. It says identify the domain of the graphed function. So if we would take a look, it's the same picture. What is the domain? So we start on the very farthest left and we go all the way to the farthest right, looking at the x values. So the very least x value is -5. There's no break in any x value, and we end at x is 7. Notice that we are including the -5 and the 7, and then the range. So notice that the smallest y value is -4. There's no break in the y values, and then we go all the way up to 4. And so we are including those. And make sure that you list any questions for me.